we are currently in lesson 3 of the Math 120 workbook assignment, and the heading is limit of function of real variable. Limit of function of real. As I'm solving this assignment, I'll also be teaching limits so that you can understand the concept of limit and continuity. Now, every function we should know has a limit value. Please no noise. Please no noise. Can you be the people making this noise and show the audience? You're doing like this. Please stop making noise. Please, they are the one starting the class. Now, activity 3.1. Lesson 3. Lesson 3. Activity 3. Class, we're asked that given the function f of x equals lim x squared minus 1 all over x minus 1 as x tends to 1. We're asked to evaluate lim f of x as x tends to 1 for the following cases. I, x less than 1. Now I'll explain what they mean by x less than 1. I, x greater than 1. Sorry, x equals to 1. And I, x greater than. Now, you must understand that there are two types of limits. We have what we call the right hand limit and the left hand limit. The right hand limit and the what? Left hand limit. Now, anytime they give you a question on limit, expect to be given what we call the limit point. Every limit question comes with a limit. The limit point is what is usually written below here, x arrow 1. It means the limit point. This x arrow 1 means that x tends to 1. So our limit point is 1 plus. Without the limit point, you cannot have the limit value. Because when you have to evaluate the limit of a function, you are being asked to evaluate the minimum value of that function as the limit point tends to a particular number, a constant. Class. So if you are saying that lim, let me give another example. For example, lim 3x plus 1 as x tends to 2. Class, what this means is that we should find the limit of this function 3x plus 1 as x tends to 2 means x is approaching 2. As x tends to 2 means x is approaching. Now, do you know that x can approach 2 from two possible directions? If I draw a graph like this is my origin 0, this 1, this 2, this 3, this 4, this 5. This minus 1, minus 2, minus 3. Now our limit point is 2 plus, right? Let me bring out 2. How many possible ways can we get to 2? We can get to 2 from the left. So x can approach 2 from the left, and x can also approach 2 from the right. Class, anytime our x approaches our limit point from the right is the right hand limit. Right hand what? And class, the right hand limit, because it's coming from the positive axis. Remember, this is the origin. From the origin to the right is the positive axis, right? From the origin to the left is the negative. So anytime x approaches our limit point from the right hand side, we have our right hand limit. And anytime x approaches our limit point from the left hand side, we have our what? Left hand. LHL means left hand limit. RHL means right hand limit. So x can approach our limit point from two possible directions, from our right hand side or from the left hand side. Now, class, how do we recognize that we are being told to find our right hand limit, and how do we recognize they are being told to find left hand limit? Class, anytime you see your limit point carrying a positive sign, it shows right hand. It shows what? If you are told x tends to 2 plus, it means that those numbers that are greater than 2, find the limit of this function from as x tends to those numbers that are greater than what? And anytime you see x tends to 2 minus, what does it mean? Left hand. Because I told you that the left hand limit usually comes from the negative direction, right? The right hand limit usually comes from the positive. So we use positive to represent right hand, and we use negative to represent left. You see, we're not just solving the assignment, we're explaining limits. So this assignment is an opportunity to teach each topic step by step. That's why we advise you to be in class as well, please. Be in class. Be punctual in tutorial, exam is closed. Be punctual. Now class. So you can see that the right hand limit deals with greater than 2, left hand limit deals with less than. So you see that I can interpret this first question. X less than 1 means approaching 1 from the numbers less than 1. That's what this x less than 1 actually means. X greater than 1 means approaching 1 from numbers greater than, and x equals to 1 means the exact limit point. Class, for the limit of a function to exist, the right hand limit must be equal to the left hand limit. For the limit of a function to exist, the right hand limit must be equal to the what? Left hand limit. So class, if this function exists, whatever we got as the limit of this function must be the same as the right hand and the left. If that's not the case, then the limit of the function does not exist. You go to your manual, you see where they said on page 11, lesson 3, they said the concept of limit of function of real variable tests the behavior of a real valued function. For example, f of x, when the independent variable in the domain approaches a particular value, say c, which may or may not necessarily be the domain of f. It is possible for the variables in the domain of f to approach the point c from either the right or the left of the number line, which gives rise to the right hand and left hand limits respectively. I'm reading from your manual now. The function f is said to have a limit when the two approaches gives the same limits. It should be noted here that for the present study, dom f must be a subset of the set of real numbers and must contain numbers which are arbitrarily close to the limit point c. So class, we need to find out here. Okay, first things first, when solving limits class, you will need to substitute. Our limit point is 1, right? This one I did here was just to help you understand limits, right? Let's now go back to our workbook question. Class, when you're given a limit question like this, it's your job to take your limit point. Our limit point is 1, right? And put it into the function. How do you put your limit point into the function? By replacing it with x. Replacing x with 1. Replace x with what? 1. Anyway, see x, put 1. So we are going to have 1 squared minus 1, right? All over 1 minus. Anyway, we see x, we put 1. Are you there? 1 squared gives us 1 minus 1 all over 1 minus 1 minus 1 all over 1 minus. Now class, 1 minus 1 is 0. 1 minus 1 is also what? Class, anytime you input your limit point into your function and you have 0 over 0, it means something in mathematical terms. It means our function is an indeterminate function. Anytime you have a function 0 over 0, it doesn't mean you are wrong, it just means that your function is indeterminate. And we have 2 ways of tackling indeterminate functions. One, we have what we call the L'Hopital rule. You can also use factorization. I did have taught this in class, right? Yes. Some of these things I've done it in our class. If you've been attending our class, I've done it, taught some of these things. I'm just happy that, so you can see that it's also coming out in your workbook. Meaning anything you are learning in tutorial is an exam point. If it can come out in the workbook, it can also come out in the exam. But let's do it again for those that were not around. Anytime you have an indeterminate function, there are 2 things you can do. Either factorize or you differentiate. That's L'Hopital rule, means you differentiate the numerator and denominator separately. Differentiate both numerator and denominator. You only do that when you have 0 over 0. If you don't have 0 over 0, any answer you get is your final. But once you have 0 over 0 class, you come back and then differentiate. You come back and then do what? Either differentiate or you factorize. Class, if I differentiate x squared, I should have 2x. I should have what? And if I differentiate minus 1 is 0. Is what? To disappear. All over differentiate x, I have should know that the differentiation of x gives you 1, and the differentiation minus 1 is also what? 0. Why is this minus 1 is minus? Why is it 0? Because they are constants, right? Please note that the differentiation of a constant always gives us 0. Anytime a constant is differentiated, the constant disappears. The differentiation of a constant causes the constant to no longer exist. It disappears. Who are constants? Constants are numbers that do not have x. That's why you're no longer seeing minus 1 and minus 1 here again. But differentiate x squared, you always have 2x. Differentiate x, you always have 1. So 2x over 1 gives us what? 2. After differentiating, now come back to your limit point and replace the limit point with what you have differentiated. That will be 2 into bracket what? 1. 2 into bracket 1. What is 2 times 1? 2. So therefore we say that the limit of x squared minus 1 all over x minus 1 as x tends to 1 when x is less than 1 is 2. But class, how do you report this first one? When x is less than 1 means that it's coming from the left hand side, right? So your reporting will be x tends to 1 minus, to show the lecturer that you understand why they say x less than 1. X tends to 1 minus, for I is 2, still using the same solving. X tends to 1 is for I, so you say lim x squared minus 1 all over x minus 1 as x tends to 1. Don't put minus or plus, that's the real limit. And the third one, x greater than 1 will be lim x squared minus 1 all over x minus 1 as x tends to 1 plus. This positive is showing that this is the right hand. This negative is showing that this is the left. And this one is showing that this is the real limit. Now don't forget that they all have the same answer. Do you know why? For the limit of a function to exist, the answer you get in the left hand must be equal to the answer you get in the right, and must be equal to the limit itself. It's a condition for limit of a function to exist. The right hand limit must be equal to the left hand. So let's not be surprised that these 3 questions, the answers must be the same. If the answers are not the same, then we'll just say the limit does not exist. So it means that the answer to this must be the same answer to this, must be the same answer to this. Just little minor differences. Little what? Minor differences. What are the minor differences? In this first one, there will be a minus on the limit point, showing that it's from the numbers less than 1 from the left hand side. And the second one, there won't be minus or plus, just carry 1. And the third one should be 1 plus. But all of them will be differentiated as usual, and you have the same answer. So you're going to write the same steps for these 3 processes and get the same answer. Just have a little tweak in the limit point. This guy will carry a minus in the limit point. This third guy will carry a plus in the limit point. Why this middle guy will just carry 1, to not carry plus or minus. If you do this very well, we have just answered that is 3.1. Actually 3.1. Now, class, if you go to 4, still on actually 3.1, IV. We're asked to compare our answer with f of 1. F of what? We're asked to compare our answer with f of class. What's f? F is what? F of x is what? X squared minus 1 all over x minus. Class, f of 1 means anywhere we see x, put 1, right? This will be 1 squared minus 1 all over 1 minus. 1 squared minus 1 means 0 over. Class, f of 1 actually does not exist. Because 0 over 0 means undefined. Because if you point 0 over 0 in your calculator, you're going to have undefined. Does not exist. So comparing f of 1 with limits of this function, class. And class, anytime you have 0 over 0 for a normal function, you are not allowed to differentiate, class. The only time you differentiate is when you say you find the limit of the function. You have 0 over 0, you can further on by different. But if they say you just have to find the f of a particular function without limits, you are not allowed to differentiate. If you have 0 over 0, your final answer is just undefined. So if you are comparing our answer here with what we got here, our answer here is undefined, while our answer here is what? A real number 2. That's the comparison between the two. Thank you very much. In the next video, we'll be doing the second question 2 of activity 3.1 lesson 3. Thank you very much.